information between them. Some of the information sends notes, some of it sends commands, like make it louder, make it softer, and so on. And the notes are specified in the range 0 to 127 and are mapped onto audible notes that you can hear. So middle C is a 60 there. We can see that an E is a 64 and a G is a 67. So if in Sonic Pi, which is standard on the Pi now in the education submenu, you simply load it up, and if you type play 60, play 64, play 67, and then say go, that's exactly what it does, like that. Oh, incidentally, I forgot to reset one thing about it. When you actually start off Sonic Pi, it looks like that. And you get an output window here which shows the output this produces and any errors which are generated down the bottom. That played 3 notes together. If we want them one after the other, we simply tell Sonic Pi to go and twiddle its thumbs and go to sleep for a little bit between one and the next. Like that. Oops. And if we play that again, we now get 1 note after the other. Like that. But you can imagine if you're playing lots of notes, it gets rather tedious to have to keep on typing play, sleep all the way through. And so, if I look at my little crib down here, which just saves me doing some typing, and make sure I get it right. If we come down here and I simply copy this and paste it in here, then we can see that you can make things slightly more manageable by using the command play pattern, like that. One gotcha if you're just starting off here, you must have a space in there before the list of notes that you want to play, which are placed inside angled brackets. And the speed of the notes is given with the tempo command just above there. So if we play that, then that just plays a little scale like that. And if we make the tempo smaller, like that, then it'll take a bit longer to play. Like that. And we can go one stage further than that. We can add another parameter to this play pattern command and turn it into what's called a play pattern timed command. You may say, why do you want that? Well, the answer is that with the first one, all the notes are the same length. In this example, they would all be the same length again too, 1/10 of a second, so this will sound rather fast. And we can slow it down by changing that number there and making it take twice as long. But the real interest is that that second list, the way it works is that when you read the first note, it looks at the second list and reads the first entry there. When you play the second note, it looks at this list and reads the second entry. Oops, there isn't one, so it goes back again and starts reading for the first one. And that way, one number makes all the notes sound the same length. But if we put in a second number like that and play again, we get higgledy-piggledy, like that. You'll see that every second note is shorter than the first one. Perhaps if we make those shorter again, you can hear it more clearly, like that. Like that. Okay? The next thing we can do is that we can actually change what it sounds like. You may have noticed on the right-hand side that it says Play Pretty Bell. That is the default synthesizer which is used in Sonic Pi if you don't tell it to do otherwise. Well, I am going to tell it to do, I always do the same, I've gone pasted instead of pasted, right? Let's see. Oh no, I did it even worse than that. Copy. Try in there, that's what I pasted. That's right. This time I'm telling it to use another synthesizer called Sorby, but if you look on the right-hand side, you'll see that it's going to say playing Sorby. You'll notice one other thing, or you'll hear one other thing. It played them backwards, which we can do simply by putting in the parameter dot reverse at the end of that, like that. And the final of the simple constructs I want to show you here, and these you can all get from the excellent work that Carrie's done, producing a teaching pattern plan for this, and that's got some examples, and there's also in there a cheat sheet for the Sonic Pi that gives the basic commands that it can use. I've kind of got it wrong again, I'm getting all thumbs and fingers here. Copy it, and paste, that's right. This one does things more than once, simply a simple loop, like a for next loop, except the syntax is fi dot times do. And another parameter here, you can use a shuffle command where it reads each of these notes in a random order, each one once in a random order, and produces that rather nice effect there. So far we've played one note at a time, but any decent music is going to have some harmony to it and have more than one note at a time in it, and that is achieved by using a thread command in Sonic Pi, where you start off one bit of music playing, and you go on and say, well, now I've started that off, start another one at the same time. And if we copy this example here and paste it in, you can see that we've got a play pattern time command, all the notes the same length, there's only one time there, and this is going to sound and say da 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 da, so I think you can guess what it is. And having played the first line, we start off the same thing again. Here's the whole tune again, and that starts off at the same time as the main tune continues with the second voice. And so the effect is that we're going to play them both together, and it sounds like this. Now you'll notice that there's a lot of crackling here, and this is a consequence of the fact that the Sonic Pi is working pretty hard doing all this, and out of the audio you do tend to get crackling. You can cut it down a bit two ways. One is to use the sawbell synthesizer, which is less taxing than some of the others, and so it doesn't crackle as much. And the second is, which I only discovered this fairly recently, if you right-click the arrow there, you can actually turn off the output and error windows, and so it's got less to do. It hasn't got to generate that text, and there's more time to devote to the music, and it's slightly better. Sonic Pi has also got 8 workspaces as it comes. I've used one for the first one, because I've already filled the others up with other things. You can discover things and explore things yourself. One of the things is that Sonic Pi is written in Ruby, and so you can use Ruby constructs in driving it. And one of these is that you can actually define sections of music by name. And here I've got Frere Jacques again, but I've defined the first line and called it A. And I've put in the synthesizer that I want to use there as well. I've defined the second line, disregarding the repeat, as B, the third as C, and the fourth as D. So the whole thing comes up as AA, BB, CC, DD to play it. And you can get the structure of what you're doing much more clearly at the bottom here. One other thing is that you'll see that I've had to define the synthesizer in each section. Each definition is separate from the main program, and it will default to the pretty bell unless you tell it otherwise. And so that I don't have to type in the name each time, I use the variable for it. And the other thing you have to do is to use what's called a global variable that applies right throughout the whole script you've got here. If you just put s equals Sorby and you put with synth s in the A section, it will give an error because the two s's will be different. But with the $sign in front of it, it applies all the way through. And this plays with all three. Now I can see this man is looking at his watch, so we'll just stop that and move on to another couple of examples which I'm going to play. The first one is a larger version I did, which plays Strawberry Fields Are Forever, Beatles, and this starts using chords and threads together, and sounds like this. Again, you can look at all of these. They're on a site which you can get from that WordPress site, and they are heavily commented, so that although I haven't got time to go into great detail here, there are lots of useful comments if you want to write your own as to what works and what doesn't work. I'm going to stop that because I want to give you a flavour of just the sort of things that you can do with Sonic Pi. Here is another piece which is a Bach piece, and here at the beginning I've actually defined the lengths of all the notes and put them in variables. It's much faster when you're typing to type C for a crotchet than to type 0.25 or whatever it is you've assigned to it. And the second thing is I set up all of these with a multiplier, so that having written the music, if you put it in a defined section, defined tune, write your tune, use these variables C for crotchet, S for semiquaver, and so on. If you say, I want it faster, you just change the value of M and redo it again. You don't have to retype the whole thing. You change the variables and say tune, which plays the tune, and it'll play it all faster for you. And so here's what this sounds like. Time to listen to them. I'm afraid I'm going to stop it because I want to show you just the full extent that you can get with Sonic Pi. I'm just very quickly going to delve into 3 more examples, play a little bit of them and stop. This one uses the Play Synth FM, which is a really wacky thing that you can have all sorts of fun with. It has further parameters which you can use and will produce some really zany sort of sounds, like this. It's also you've got some play patterns in there in reverse and in normal order and shuffle order, which are quite nice for making just playing around with some music like that. There's the play pattern, forward in reverse and in random order, and then some more synths at the end. And then finally, this is a 4-next loop, or a timed do loop, playing random notes within an octave, which slowly starts to rise. Everything is played by this central line in the middle. The whole lot is played by that central line in the middle. It plays random notes within an octave, and it does that 5 times, and then raises it 6 octaves, an octave at a time. So it's gradually going up, then it'll come down again, back to the bottom. And then the final one, which I'll leave you with, is one which explores in more detail these divisor parameter in the play synth, and this produces a piece that I'll just start playing. I haven't got time to explain it, but it's all explained in comments in the piece on the website. And as that plays out, I think that's all I've got to say. So I hope you enjoyed it.